Alright, in this video, I am going to talk about average value of a function and mean value theorem. Okay, guys. So let me review about the let me give you some review about the area of a rectangle. Okay, so suppose area is given as 16. Okay, so I want to find out the length and height of the rectangle. So this is the length, or this is the length, right? This is the height. Okay, so if area is given and if the rectangle is placed on the coordinate axis, above x-axis, then can you find out what is the height? So what is the length first? How do I find out the length? So you see that this is 0, right? This is 0. So this length is 2. Okay, the overall length up to here is 10. So how much is the length in the middle? So that length in the middle is basically the length of the length of the rectangle, right? So how would I write that? Is 10 minus 2, that is 8. You see that? So this length is 8. So what we have now is area is 16, length is 8. So what should be the height? How do I find out that? We know that area equals to length times the height, right? Or length times the width, you can write. So area is given as 16 and length we found as 8, and now I want to find out the height, right? So what I did here is, so height is 16 over 8. So height is 2. So I found height as 2. So basically what formula did I use? Height equals to area over the length, right? That's the formula I used to find out the height. Now what do you mean by the average height? So here the average height means, since the height is same everywhere, height of the rectangle is same everywhere, so the average height is basically the 2 here, right? But to find out the average height or the height of the function, what we have to do is we have to find out the area and then divide that area by the length. Okay, divide area by the length. Now I want to find out the average height of this function here. So how do I find out the average height? Because you see that some of the heights are pretty short, right? Some of the heights are tall. You see that? So what will be the average height? Average height must be the height between the taller and the shorter values, right? Somewhere here maybe. That is the average height of the function here, right? Between a and b. You see that? So to find out the average height or the height of the function in that interval a to b, that is the average height, what we do is we find out the area divide by the length, right? What is the area? Area is the integral, right? So the area is basically the integral from a to b, f of x, and then dx, right? And what is the length of the interval? Length of the interval is, the total length is b, and then minus a will be the area length between a and b. So that will be b minus a. That's how I find out this formula. So the height or the average height here is basically the average height. Let's say it's also called average value. Okay, average value is 1 over the length of the interval and then times the integral or the area, right? So to use this formula, the f of x must be continuous on the interval ab. Okay, so this is the formula to find out average value of a function. Next, we will see some examples on how to find average value of the function. Let us see this example. The function is fx equals to 16 minus x squared. Okay, and you want to find the average height or the average value of this function in the interval -4 through 4. Okay, so how would the graph of this look like? So the graph of this function, if you draw the graph of this, it will look like this. So this is y-axis, this is x-axis. Okay, so since this is a quadratic with a negative value of the leading coefficient, so it will be a parabola that opens downward, right? So it will look like this. So this is a parabola that opens downward. You see that? So this is that parabola that opens downward. So this is -4, +4. You want to find out the average height, because you see that close to +4 and -4, the height of the function is shorter, and close to 0, the height is taller. So we need to have the average is somewhere between shorter and taller, right? Maybe somewhere there. You see that? All right. So find the average value of the fx equals 16 minus x squared. 16 minus x squared in the interval -4 to 4. We will use this formula. By the way, I forgot to mention that to use this average height formula or the average value formula, you need to have the function continuous in the interval AB. Okay, if it is continuous, then the integral exists, right? You can find the integral of a continuous function in a finite interval. So that's what we need. Okay, so let us find out the average height or average value of the function. So the average here is equals to, so what is the length? The total length is b minus a. This is like b, this is like a, right? B minus a is 8, right? So you will have, so negative 4 to positive 4, and then 16 minus x squared, okay, and then dx divided by 8, right? So 4 minus negative 4. You see that? So so this is 1/8. I'll pull that out, and then I will find I'm going to find out the integral of this. What is the integral of 16? So 16x, right? Minus, what is the integral of x squared? So that will be x cubed over 3, and the limits of integration are negative 4 through positive 4. You see that? So this will be basically 1/8. Now you plug in positive 4 to all x, and then do minus, and then negative 4. So 16 times 4 minus 4 to the cubed over 3 minus, now you plug in the lower limit. So let me start with the parenthesis. 16 times negative 4, and then minus negative 4 to the cubed over 3. That's what you get. Okay, so if you simplify this, what you get is 1/8. So 16 times 4 is 64 minus 64 over 3. You see that? Minus, what is 16 times negative 4? Negative 64, but this is negative, so you'll get positive 64. You see that? And then how about here? So negative 4 to the third is negative 64, and then minus times this negative sign times negative 64 over 3 will be positive 64 over 3, but there is negative, so negative 64 over 3. Okay, this is what you get. So if you simplify this, what do you get? So this is negative 64 over 3 minus 64 over 3 will be negative 128 over 3. You see that? And then 64 plus 6. So if you use calculator for this, you will get this. You will get 32 over 3. So this is the average height of this function, or this graph between negative 4 and positive 4. Okay. So how about this example? Find the average value of the function fx equals sin x in the interval 0 to pi. Do you know how does the graph of this fx equals sin x look like? Because if you have that, sin 0 is 0, you want to find out between 0 and pi, right? So, and then add pi over 2, sin is 1. So it will look like this again. Okay, so you want to find out the average height of this. So the average height may be because you see that near 0 is the average, the height is almost 0, right? Very short. And near pi it is short, and near pi over 2 it is tall, right? This is, so we need to have our average height somewhere like this between the highest and lowest height. So let's see how much would that be. Okay, so the average equals to 1 over b minus a is pi, because this is like a and this is like b, right? And then integral 0 to pi sine x dx. You see that? So that will be 1 over pi, and then 0 to pi. So let me find out the integral of sine x. Who remembers the integral of sine x? This is basically negative cosine of x, right? And then 0 to pi. Okay, so how much do you get that? 1 over pi. And then now plug in pi. So negative cosine pi, negative cosine of pi. You see that? And then minus negative means this will be positive, right? Because when you take the upper limit, you just plug in here and then do minus and then take the lower limit. So when you do minus and then take the lower limit, that has also negative sign. So cosine 0. Cosine 0. You see that? So that will be 1 over pi. So what is cosine? Negative cosine of pi. Cosine pi is negative 1. So there is another negative. So it will be positive 1 plus 1. Cosine 0 is 1, right? So basically you get 2 over pi, which is smaller than 1. Because at pi over 2, the height is 1. So the average height is 2 over pi. You see that? This is how we find out the average height or average value of a function. So the next thing we want to do is mean value theorem. What does it say? So it says that if fx is continuous on the interval AB, then there exists a point C somewhere where the average height of the function is equals to height of the function at C. Okay, so what it says is if the function fx is continuous in an interval AB, then you should be able to find out the point C where the height of the function at C is equal to the average height of the function. And that is true, right? I mean, since it is the average height, since this is average height, the average height must be somewhere in the middle, right, between the lowest and the highest values. So that is the point C that we are able to find out. Okay, let us see some examples on the use of the mean value theorem. For the mean value theorem, in short we call MVT. Okay, mean value theorem. Okay, so what it says is use mean value theorem to find out C for the function fx equals to x cubed on the interval 0 to 5. So what we do is we use that mean value theorem. So what is A? A is 0, right? B is 5. So 1 over b minus a. So let's write down the solution. So 1 over 5 minus 0 integral. So 1 over 5 minus 0 and then integral. What are the limits of integration? So the limits of integration are 0 to 5, right? F of x is x cubed dx equals to f of c is c cubed. You see that? I'm just plugging into this formula. So I'll find out the value of c. So 1 over 5, you see that? And then what is the integral of x cubed? You'll get x to the 4 over 4, right? And then inside the this is inside the bracket. And then outside we have 0 to 5 equals to c to the cubed. So how much is that? Well, how do I do that? Is just plug in the 5 upper limit. So you get actually 5 to the 4 over 4, right? And then minus 0 to the 4 over 4. See that? Equals to c to the cubed. So what I did is I plug in the upper limit on the x, and then I did minus, and then I plug in the lower limit. Okay, so 1 over 5. So this is or. So 1 over 5. How much is that? This is basically 0, right? So this is 5 to the 4 times 5 to the 4 over 4 equals to c cubed, right? So what do you get? So you divide 5 to the 4 by 5, so you cancel one of those. So 5 to the cubed over 4 equals to c cubed. How do I solve for c? Just take the cube root, right? So I would do cube root of 5 to the cubed over 4 equals to c, right? So how much is that? You can distribute this cube root to the top and bottom, right? If you distribute to the top, that 3 and 3 will cancel out, so you'll get 5 over cube root of 4 equals to c. This is what you get. That is the value of c, where the height of the function at c is equal to the average height. Okay, let us do one more example. So use mean value theorem to find out c in the given interval of fx equals to 16 secant square x on the interval negative pi over 4 and then pi over 4. Exactly the same way, right? So what you do is solution. You do 1 over b minus a, pi over 4 minus negative pi over 4, and then integral negative pi over 4 through pi over 4, 16 secant square x, right? And then dx. What do you get? So pi over 4 plus pi over 4, right? Because there is double negative. So that is pi over 2. So 1 over pi over 2. And then I want to integrate this. I will pull this 16 out, right? What is the integral of secant square x? That is tangent x, right? Tangent x. And then negative pi over 4 through pi over 4. So this is the integral, right? But this must be equal to f of c. What is f of c? Just 16. This must be equals to 16 secant square c. 16 secant square c, right? Because what does the formula say? So you find out the average height, right? And then write down equals to f of c. F of c is just replace x by c there. So what do I get on the left side? It is basically 2 over pi, right? Because this is the 1 over the fraction. So it will be like 2 over pi. Let me write that way. this implies 2 over pi times this 16, and now plug in the pi over 4. What is tangent pi over 4? Tangent pi over 4 is 1, right? And then minus tangent negative pi over 4 will be negative 1, right? So this is what you get. So this is equals to 16 secant square c. Okay, so how much is that? This is basically, this one is basically 2, right? So 2 times 2 times 16. So that is on the left side, you get basically, let me write down here. On the left side, you get basically 64 over pi equals to 16 secant square c. All right, that's what you get. So now how do I solve this? Divide by 16 on both sides. So let me do that. Divide by 16, divide by 16 here. So it will be 16 times 4. So 4 over pi equals to secant square c. Okay, so how do I solve this? Is take the square root. You will get 2 over root pi, right? Because I'm taking the square root on both sides. 2 over root pi equals to secant c, and then take secant inverse on both sides, or arcsecant on both sides. Therefore c equals to secant inverse 2 over root pi. That is the final answer. Okay, so let me talk about some of the notes on the definite integral and the area. So this function f of x, this is the shaded region, right? How do I find out the integral of the fx over x-axis and then between a and b? Is a to b fx dx. Suppose this integral, value of this integral is 10. Basically, if you are finding the value of the integral or the integral of a function fx under the curve under this curve and over x-axis between a and b, then this is basically the area, right? Area under the curve between a and b. Okay, suppose this value or the integral or the area, this is 10. Then if you flip this, if you reflect this about x-axis, this is the graph you will get. Okay, so do you remember from college algebra that if you are reflecting a function about x-axis, then you multiply the right hand side by negative sign, right? You change the right hand side by negative sign. You see that? So I denoted that by gx, and then I wrote negative f of x. This is just reflecting down, reflecting about x-axis. This is what you get. So can you guess what will be the integral of this over this curve and under x-axis? Just the change by negative sign. Okay, how? Because I want to find out a to b gx dx. Okay, that will be a to b gx is negative fx dx, right? I pull that negative sign out, so a to b fx dx is negative and then 10. So basically what it says is, if you are finding the area below x-axis, that will have the negative sign, or the integral below x-axis, that will have the negative sign. Okay, that's what I wanted to say. Look at this. What is given here is from a to b, the integral value, this value, the integral value is negative 5, because this is below x-axis, so I'm taking that as negative. And from b to c, the integral is supposed 10. Now, how do you find out the integral between a and c? So to find out the integral between a and c, how do you do that? Is you will do a to b integral and then plus, and then you do b to c. Okay, so the a to b is negative 5 plus b to c is positive 10. So 10 minus 5 will be 5. This is what you get. Okay, this is like f dx and then f dx. Okay, some part of the f is below x-axis and some part of the f is the above x-axis. That's why if you want to find out the total fx between a and c, so what you do is you break, and then you separate that below x-axis and separate that above x-axis, and then you add them. So this is negative 5 and this is positive 10. If you add that, you will get positive 5. This is how you get that. But when you do the absolute value, you see that absolute value here? If you are finding the integral of the absolute value of fx from a to c, then absolute value will change all the negative sign into positive sign. So how would that work? Is you will do a to b absolute value of fx, and then plus b to c absolute value of fx. okay, dx. If the function is negative, this absolute value will make it positive, okay. So this will become positive 5 instead of negative 5 because of the absolute value is removing the negative side, and then plus this is 10. That's how you get 15. Okay guys, that is one of the note that I wanted to share.